Hey guys, Mr. Backwork here. In this video, we're going to look at the quotient rule with negative exponents. So just a quick reminder, the quotient rule says when you're dividing things that have exponents on them, as long as the bases are the exact same, you're going to subtract the exponents, but you're going to leave the base the same. So in this first example, we've got a to the negative 10th divided by a to the 4th. So we check to see that our bases are the same. They're both base a. So I'm going to leave the base the same, but now I'm supposed to subtract those exponents. So I'm going to take negative 10 and subtract 4 from it, so I get negative 14. So we have a to the negative 14th power. Now, we don't typically like to leave our answers with negative exponents in there, so we're going to think about this as being a fraction, and we can make anything a fraction by putting it over 1. I want to move this a down to the bottom of the fraction to help get rid of that negative exponent. So when we do that, the a base stays the same, but the negative 14 power turns into a positive 14. Now we need something on top of the fraction, and right now there's technically a 1 in front of that a, so I'm going to leave the 1 on top of the fraction. So we get 1 over a to the positive 14th power. Now as we look at our next one over here, x to the negative 13th divided by x to the 4th. Again, we check to make sure that our base is the same. It is, so we leave the x. We're going to subtract those powers. So negative 13 minus 4 is negative 17. And again, we don't like to leave our answers with negative exponents in it. So we're going to take that x and we're going to move it down to the bottom of our fraction. And when we do that, the negative 17 power becomes a positive 17. There's technically a 1 in front of this x right now, so that 1 stays on top. So we get 1 over x to the positive 17th power. Looking at our next example here, I've thrown some extra numbers in front of those variables. So we're going to use our associative property here to help us simplify things down. So the associative property says that we can make groups out of things. So I'm going to group the things that are like terms. So I'm going to group the 6 and the 2 together. So we would have 6 over 2 as that first fraction. And then I'm going to group those x's together separately. So x to the 13th over x to the negative 4th. Now when we reduce this down, 6 divided by 2, well, that just reduces down to 3. And then when I take care of those x variables, x to the 13th over x to the negative 4th, these are both base x's, so we leave the x the same. We want to subtract those exponents. So we're going to take 13 minus negative 4, and that double negative in there turns into addition, so we get to the 17th power. Now, we don't have any negative exponents in our final answer, so there's no need to rearrange anything. So our final answer is going to be 3x to the 17th power. Now, taking a look at our next one, we have negative 8y to the negative 12th over 4y cubed. Again, we're going to make groups out of the like things, so I'm going to start with those numbers. So we're going to have negative 8 over 4 as our first fraction, and then I'm going to deal with those y variables separately. So y to the negative 12th over y cubed. And let's look at reducing down this first fraction, that negative 8 divided by 4. Well, when we take negative 8 and divide it by 4, we're going to get negative 2 as our answer. Now looking at these variables, y to the negative 12th over y to the 3rd, those are both base y, so we're going to leave the y the same. If I take negative 12 and subtract 3 from it, we're going to get negative 15 as that power. And like we talked about before, we don't like to leave our answer with negative powers if we can avoid it. So we're going to look at this whole thing as being a fraction over 1. The y has that negative 15 power on it, so we're going to move the y down to the bottom of the fraction. So the y goes on bottom. That negative 15 power turns into a positive 15 when we move it. We still have this negative 2 that's hanging out in front. That doesn't have a negative power on it, so that's going to stay on the top of the fraction. So we're going to have negative 2 over y to the 15th power. Looking at this next example, we're going to do the exact same thing. We're going to look at making groups out of the pieces in here. So I'm going to start with those numbers, the 15 and the 9. So we have 15 over 9 as our first fraction. And then for our second fraction, we're going to look at those z variables. So we have z to the 8th over z to the negative 3rd power. looking at doing that division with the fraction, we can't really take 15 and divide it by 9, but we can reduce this fraction down. Each one of these numbers is divisible by 3. So when I take 15 and divide it by 3, I'm going to get 5 on the top of the fraction. When I take 9 and divide it by 3, I get 3 on the bottom. Looking at dealing with these z variables, z to the 8th over z to the negative 3rd, we want to leave the base the same, so z, and we want to subtract those exponents, so that's going to be 11 for our power. Now this is still technically a fraction, it's just over 1 now. And I want to take these two separate fractions and multiply them back together. So if we multiply what's on top, 5 times z to the 11th, we just get 5z to the 11th power. And if I take 3 times 1 on bottom, we just get 3. There are no negative exponents, so we don't have to worry about moving anything around. Our final answer is going to be 5z to the 11th all over 3. One more example in here to take a look at. Now this one's a little bit more complicated because I added in a second variable there. We're still going to make groups out of things, so I'm going to start with those numbers. So I'm going to make a fraction 18 over 6. Then I'm going to look at that first variable, which is x. So I'm going to take x to the negative 8th over x to the 5th as my second fraction. And then for my last fraction, I'm going to deal with those y variables. So y to the negative 12th over y to the negative 6th. Now I'm going to deal with these piece by piece. So if I take 18 and divide it by 6, I get 3. If I take x to the negative 8th and divide it by x to the 5th, I want to leave the base the same, but subtract those exponents. So negative 8 minus 5 is negative 13. And then if I deal with those y's, those have the same base, so it's still y. I want to subtract those exponents. Negative 12 minus negative 6, double negative turns into addition, so we're going to end up getting negative 6 as the exponent on there. Now what I notice is that we do have a couple of negative exponents to deal with. So I want to think about this as all being a fraction over 1. We're going to move the x down to the bottom of the fraction since it has that negative 13 power. But when we do that, the power becomes a positive 13. I want to move that y down to the bottom of the fraction because it has that negative 6 power. But when we do that, it becomes a positive 6 power. The 3 does not have a negative power on it, so it stays on the top of the fraction. So for our final answer in here, we're going to get 3 over x to the 13th, y to the 6th. That's going to be it for this video. Thanks for watching.